Alright, so rounding decimals and significant figures. So first thing we're going to talk about is decimal places. Now you all should be familiar with decimal places. So the idea of a decimal place is each decimal place represents a place value. Alright, so the first place after the decimal place is tenths. So how many tenths are there? And then the next one is hundredths, because you have a decimal system, it's now the 10 hundredths, and then thousandths, etc. Okay, so it just represents a value for each one. So we can use decimal places to round decimals, obviously, so that we can estimate answers rather than having to write many decimal places. So we don't want to always have to write 10 decimal places, or 20 decimal places, or 16, or however many they might be. We just want to be able to write in an easy way. You generally only need a couple of decimal places. Right? We don't want it to be that accurate. So, when rounding decimals, if you want to round to the second decimal place, you look at the one next to it. You look at the third decimal. And if it's 5 and above, you round that second decimal place up. If it's 4 or lower, the next one along. If it's 4 or under, then you round that decimal place, you keep it the same. Alright, so 5 and above, you have to round up, 4 and below, you keep the same. Alright, so we're going to do a couple of examples here. And so if you look at this one, 4.563. 4.563, so that's 3 decimal places. It's saying round to 2 decimal places. So if you write it here, 4.563, right? And just to note, that is approximately, the curly equal sign is an approximately equal sign. So when we're rounding to 2 decimal places, we need to look at the third decimal place. So in this case, it's 3. So what are we going to do? Round it up, keep it the same. Yeah, we're going to keep it the same. So if the next one along is lower than 5, which 3 is, then this one stays the same. So we just write it as 4.56. Always put how many decimal places you've rounded. 4.563 is approximately equal to 4.56, 2 decimal places. Alright, next one is 6.788, rounded to 1 decimal place. So we can say, well, 6.788. Okay, so we put the curly equal sign. So if we say we want to round it to the first decimal place, to 1 decimal place, we have to look at 1, 2. So the second decimal place has 8, so what are we going to do? We're going to round up, and we're going to say the same. We're going to round up. Why is that? Yeah, because it's higher than 5. Right, so we end up with 6.8. So make sure when you're rounding as well, not to just write the numbers that you round, but you have to write the rest of it as well. So you can't just write 0.8 because you rounded that place. You have to put the whole number. So it's approximately 6.8, and we have to do to 1 decimal place. Okay. So again, this is looking over things we've looked at before, making sure we're familiar. When you're rounding, whether it's significant figures or decimals, always look at the next value of the one next to it. 5 and above, you round up. 4 and below, you just keep it the same. Okay? How to do this? Now we're going to look at significant figures, and some have had trouble, and some in this class had trouble last year. That's fine. So we're going to look over it again. The significant figures, instead of using decimals when we round it, we can only use it when we have decimal places. There's no point saying round 13,560 to 2 decimal places, because it doesn't have any decimal places. But sometimes a useful way of looking at numbers is by rounding them without writing all the numbers. So for example, at PAC, we say we have 1,300 students. Now, is that correct? Is it 1,500? I mean, whatever it is, I thought it was about 1,300. Alright, so 1,300 students. Now, is the number exactly 1,300? No, it's not. It's probably about 1,280 or something. 1,280 something. Okay, 1,270, whatever it is. But that's not really, we don't really care about those details. All we want to know about the population of the school is approximately how many people there are. So to the nearest 100 is a useful estimate. So we say, well, 1,300 is a useful number to have. And so it's not exactly 1,300, but it's a good estimate for our purpose. Same with the idea of if you go to the cricket or something, and they say you have 20,000 people in the stadium, it doesn't mean there's exactly 20,000. We've just rounded it to that number because we're not really interested in each individual down to the smallest detail. We're interested in approximately about 20,000, approximately 25,000 people. And that's what significant figures helps us to do. Okay? So we need to just go over how we count significant figures. So I'll put up an example of a number here, and then we'll do it a couple of times. So let's put something like this. Alright, 4,345,260 is the number that we have here. Now, to count significant figures, you start at the left and find the first non-zero digit. This is significant figure 1. So we start at the left and we look. So this is significant figure number 1. The 4 is significant figure 1. Every digit after that is counted significant. Alright? So every digit after that we count as significant. So that's the first thing. So that's the 3 here is the second one. The 4 is the third. The 5th is the 4. 5, 6. Alright, so far so good. And 0 digits between non-zero digits are significant. So if you have a 0 between two non-zeros, then you count it as significant. But there's none here, so we won't worry about that for the moment. Now this one is a whole number. Zeros at the end of the number are not significant when it's a whole number. So when you get to the end, we counted 6 significant figures. This 0 is not counted as significant. The reason is it doesn't give us any information about the number. All it's doing, that 0 is just holding the place. It just says that there's no units here. And so in the information we're trying to find, it's not significant. We're not really interested in the fact it's 0. It just is 0 because it has to hold that place to make this number 4 million something. Alright, so this number is written to 6 significant figures. Alright, because the 0 doesn't count. 1, 2, 3, 4, 5, 6. So 7th one, the 0, is not counted. Alright. Now I'll put up another number. I'll put another one down here. Let's say 0.0080. Right? So we follow that process again. We start at the left and find the first non-zero digit. What's the first non-zero digit? What is it? D. Someone said it. Is that what you thought? 8. Yeah, you start at the left, that's 0, so it doesn't count. That's 0, doesn't count. That 0 doesn't count. The 8 is the first non-zero digit. So that's significant figure number 1. Now the next digit is a 0 as well, but what's different about this one is the 0 between two non-zeros. And so it is counted. So we count that as number 2. Number 5, well that's 3, that's counted as a significant figure. The 2 is counted as a significant figure as well. Now, the difference between whole numbers and decimals when we're talking about significant figures is that zeros at the end of the decimal are significant, as they indicate the number underneath the accuracy. They indicate greater accuracy. Right, so the fact that you write a 0 at the end of the decimal, you don't have to write it unless you're trying to show that maybe there was some other numbers after it and you've rounded it already. Or it's meant to be showing that it's more accurate. Or you're measuring down to that many decimal places. And so zeros at the end of decimals are counted as significant. And so we count that as a significant figure. And so this decimal here This whole number is 6 significant figures. This decimal is 5 significant figures. And I use the abbreviation SIG-FIG to show that I'm writing significant figures all the time. So it's showing how many significant figures are written. Now any questions? So the idea is we're identifying significant figures, and we know how many each of these have. We don't have to have decimal places, we're simply using this convention to show what's significant and what's not. Yes? At the end of decimals are counted, not at the end of whole numbers. So that's just the main difference between decimals and whole numbers. Zeros at the end of decimals are counted, zeros at the end of whole numbers are not counted. Alright? Good. Here's a couple of examples. Alright, so a couple of examples. How many significant figures are these written to? Alright, so we need to just identify that. Alright, so 5670. We start at the left, remember, find the first one. What's the first significant figure here? 5. So 5 is significant figure 1. Alright? And then the second one is 6. Third one is 7. And is the 0 significant in this case? No, because it's the 0 at the end. So that's not significant. So how many significant figures is this number written to, Chelsea? 3. Yeah, that's it. 3 significant figures. Okay? What about the next one? What's the first significant? 1. And then 2 is significant. The 0 is significant because between 2 non-zeros. 3 is yes. 4 is yes. Is the last 0 significant, Luke? The last one is. Okay, so it's not significant. And so we have 1, 2, 3, 4, 5 significant figures. The next one, 0.0053. What's significant figure number 1? 5. Yep, and it's 3 significant. Yeah, so how many significant figures is it? 2. 2 significant figures. And then the final one, Luke, what's significant figure number 1 here? 6. And how many significant figures? So you've got 6 is the first one, the 0 counted, the second, yeah, 7 counted, the 8 counted, yeah, it's the 0 counted, for sure. This is a decimal, remember? So if you have a 0 at the end, it actually is counted. Right, so remember that? The 0 is counted, so they're all counted as significant, and so this one is 5 significant figures. Alright, so that's just a few examples. Now the next section, you don't need to write, just write a summary, because it's the way you round significant figures is the same as the way you round decimals. If it's 5 and above, it rounds up. If it's 4 and below, you keep it the same. So you look at the number digit to the right of the significant figure you're rounding to, and then see if you round it up or keep it the same. Alright, so if you want to, you can drop down the points. Alright, so we want to round these very significant figures. So we want to round 674,503 to 3 significant figures. Alright, now the first question is, which is the third significant figure? The 4 is the third significant figure. Good. Alright, so that's the third one. And so we look at the next one along. So that's the one we want to round to. So we need to look at this one. Because the fourth significant figure is 5, what's going to happen when we round it? It's going to go up. Right? So I need to do my fairly equal sign again. Now this step is where some of you last year in various places, and a lot of students do this. Alright? It's important to remember that the first thing is that we are rounding this number. So whatever number I put needs to be similar in value. It needs to be an estimate of 674,503. So when I write it, 670, and then this one is going to round up to a 5. But it's also important that I need to write the zeros here, the place value holders. These zeros aren't significant, but they make this number into 675,000. If you write here 675, that's not correct. 675 is not an estimate of 675,000. That's an important point to remember. The next one we have a look at, 0.004053, the two significant figures. Alright, so we have our second significant figure is 0. And so our third significant figure is 5. And so the 0 is going to round up to 1. So we have 0.004053 is approximately equal to 0.0041. And that's the way we estimate. Okay, that's the two significant figures. And so I need to remember to always write what I'm rounding to, so 3 significant figures. Okay? I'm just going to do this last one. I won't do number 4. I'm just going to do number 3 to show you something that happens. 4980 is two significant figures. I'll write it out again. 4980. Which is the third significant figure on this one? 8 is the third significant figure. So that's greater than 5. So when it's greater than 5, it's going to round up our second significant figure. Adrian, what happens when you round up 9? It goes to 10. So what's going to happen to this number? Yeah, that's right. So it's going to be 5,000. And you can still write two significant figures, although it's also one significant figure. So in this case, rounding to two significant figures is the same as rounding to one significant figure. So just make note of that to make sure you're rounding up and then rounding up correctly. So we're going to leave it at that. If there's any questions, we'll come around. Mrs. Mills and I will come around and help you. So the exercise is 1.05, and do the third column of the questions to start.